Hi everyone. So this is Harish. I will be the trainer for today's session on artificial intelligence with Python. So before I actually go into the session, I want to talk about why Python is selected as one of the programming language for artificial intelligence for our current tutorial, because Python is one of the most popular languages used by developers today. Since it got invented, so it was invented by a person named Theodore Van Rossum. It's in 1991. So ever since its inception, it is most widely used language along with C++ and Java. So Python at present is the most used language. We have another competitor for Python, which is R, which at present is competing with Python, but Python is more popular than R. So R has some disadvantages compared to Python, but we are not going to talk about the disadvantages of R now. We are only going to talk about Python. So mainly Python is an interpreter language where users can write a line of code and run it immediately. So without actually writing the complete module. It is a high level programming language and can be run with adding complicated scenarios. So what all that you can do using other programming languages, you can do using Python. So Python is built on C programming language. Next, I'm going to talk about agenda for our today's session. So we are going to talk about the introduction to artificial intelligence, why Python for AI, and features of Python. So Python packages for AI as well. So coming to the introduction of artificial intelligence. So artificial intelligence, a little background I wanted to give. So it started in the year 1943. So even though at that time the name was not given, the first work was in 1943 was done by McCullough and Walter Pitts in 1943. So later they realized that it belongs to artificial intelligence. After that, IBM have developed a particular tool called IBM Watson, which actually won Jeopardy quiz in 2011, where it solved a complex query as well as with few riddles in it. So it's a live show where IBM displayed or showed the features of IBM Watson. And now we are going to talk about the demand of AI. So by demand of AI in the sense like when the AI gained its popularity, so there are some constraints or there are some things that drive that driven to raise for the demand of AI. So one is the first is more computational power. So every AI algorithm needs a lot of computational power. Because of the current situation we have, when compared to 80s and 90s, we have more computational power because of the advancement in the technology, and where large memory processing units in memory processing unit will come into market. Because of that driven the demand of AI, and there are broader investments that come into this field where most of the governments and companies realized the importance of AI. They started investing in AI, especially fan companies like fan, I mean Facebook, Amazon, Apple, Netflix, Microsoft. They all started investing in AI, and which actually gained a lot of interest in the research. There were a lot of research as well going in AI, which actually created a lot of jobs. Because of that, demand for AI has grown many folds compared to 2000, the beginning of 2000. And also, every company started gathering a lot of data. So they started logging the data, which actually data is the key for AI. Larger the amount of data, better the training that AI algorithms can have and better the output that they produce. So because most of the companies started capturing the data that they have, that actually helped AI to yield better results, which in turn helped in raise of demand of AI. Because of the research, but because of the broader investments, higher computational power, a lot of data availability, a lot of research also started going in this field. Invention of better algorithms happened. So because of the better algorithms, effectiveness of the solutions increased, which actually made even a non-tech companies to start investing in AI. So AI not just transformed the tech industry, but it also transformed logistics. It also transformed supply chain, transformed manufacturing, pharmaceutical, and aviation industries as well, and whatnot. Like now, AI getting implemented in every company. That's the actually major reason for the demand of AI. Now, I think by end of 2020, there will be like nearly 2.3 million jobs that are going to come into AI. They need AI engineers, machine learning engineers. So machine learning and AI are under the same umbrella, but in AI we have more deeper and more advanced algorithms where where there is no need of selection of features. So next, what is AI? So the theory and development of computer science able to perform tasks normally requiring human intelligence. So AI is something that the algorithms behave or take decisions as that of human when it comes to visual perception, speech recognition, decision making, and translation of languages. So the packages like Google Translate now even have the APIs available where you can call in the API and translate Spanish into English or English into Hindi. So all this happens at the back end. AI algorithms will be running and converting those languages into the languages that we wanted. And coming to visual perception, so computer vision algorithms which actually identifies a particular image, whether it's a dog or a cat. So those sort of outputs, if needed, we use AI. And coming to the algorithm sets, or else the technology that we have in AI, we have machine learning, which is the first architecture that industry started using. So where we have clustering algorithms, classification algorithms, and regression algorithms in it. So anything that is not deep, or else anything that is not a neural network, that most of them fall in neural machine learning. Next is NLP. So if the algorithm set deals with language or text data, then we categorize those sort of algorithms into NLP algorithms, where we do text analytics using the text. We draw sentiments out of the text. So, or else, if at all a particular corpus, text corpus is given to us, if we want to know what all the most talkative items within the text, we can use word clouds. So all these comes under NLP. And coming to knowledge base, so knowledge base is more like a database with some sort of intelligence, where all the most of the companies started implementing knowledge base, where they are storing the data, and when someone want to search the data, the information retrieval is faster, because the way that the data items are connected is has some intelligence in it, and because of that faster retrieval happens. Next comes is deep learning. So deep learning or AI are can be called as synonyms to each other, where if you use neural networks with more deeper layers, that we call deep learning. So next is computer vision. When you're dealing with images, uh, or else some visual aesthetics of the data, then we call those algorithms set as computer vision algorithms. Next is expert systems. So expert systems are those where a particular machine learning or AI tool is built, and which actually takes an interface where the user enters data into the interface and changes the decision or the output after taking the user inputs. So those fall under the expert system algorithms. So these are normal we can use any of the machine learning, NLP, or deep learning algorithms in building expert systems, but we'll have more interactivity in the expert system. So that's the reason when the decisions get changed based on the parameter input that user gives into it. For example, if you are talking about revenue earned by a particular company in a particular country, how change in GDP of that country decides, or else impacts the revenue of of the company. So if the user tweak the GDP and he can see immediate changes of revenue earned by the company, it's more the concept is called scenario building capabilities. If we give it in a tool, then we can call that particular tool as an expert system based tools. Expert system also have forecasting mechanism, where the forecast of the data get changed based on the user's inputs. Next is we are going to talk about the person who actually first coined artificial intelligence. So he's a computer scientist named John McCarthy. He coined this word artificial intelligence in a conference. He also referred artificial intelligence can be an academic topic of interest, where a lot of research can happen in this field, and most of the business use cases can be solved using artificial intelligence. So he's the first one who coined the word artificial intelligence. So next we'll talk about types of AI. So we have basically three classifications in types of AI. First one is artificial narrow intelligence. The second one is artificial general intelligence, and the third categorization is artificial super intelligence. There is a technology barriers in between each of these classifications. The first one, artificial narrow intelligence, where the algorithms are designed to perform a particular task but more effectively. For example, if we build a classification algorithm in classifying whether a particular rating given to a particular product is good or bad, or else whether he rated it's a good product or a bad product. So if you build the algorithm to a specific task and it doesn't have any other intelligence to perform apart from the tasks that it is built for, so we categorize them as artificial narrow intelligence algorithms, where the algorithms won't be having the common sense that humans have, but they can perform the task based on getting trained on the history. So whenever we train a particular algorithm, we if we take a time series data, we train the algorithms. If it is a 10 years of data, we train it on 8 years, and we forecast the next 2 years when we do it during the testing, and we forecast, if you want to forecast the further future, we forecast it for another 2 years or 3 years. So here the algorithms are built for a specific task where they are will be good in doing it. More or less, whatever the algorithms that we have seen, or whatever the AI tools that we have seen till date, nothing is any other than artificial narrow intelligence. So everything falls in artificial narrow intelligence, even Alexa, even automated cars, which actually travel without the aid of humans. So all these fall under artificial narrow intelligence itself. And a lot of start companies started investing in artificial narrow intelligence. So next is artificial general intelligence, where here the algorithms will be capable, or else will be in par with human, the same level as that of human intelligence. Whatever a human can do in when algorithms that fall under artificial general intelligence will be able to do it, like recognizing a person, moving the way that humans move. All these, if the algorithms have these capabilities, then they fall under artificial general intelligence. In order to reach to this artificial general intelligence level, we are very far till now. Maybe coming down the line, once the algorithms get improved, like a lot of research going on in this field. So we may soon reach to artificial general intelligence in 2040. That's what experts in the industry say. Whereas artificial super intelligence is something where the algorithms are much pronounced than humans, where they will be able to do, act, work more powerful or much better than humans. So just like we see in movies, maybe anyone watched Robo movie where Rajnikant do everything and much better than humans, where the intelligence answering any questions that is related to any of the fields like maths, science, any technology. So if the algorithms are capable of answering, or else capable of doing things much better than humans, then they are categorized as artificial super intelligence, where present there are constraints on the technology where we, in order to reach to that point, and there is a lot of fear around it as well. Because if once machines or algorithms able to outperform the humans, then the world may go into the hands of machines. So as we see in most of the movies, sci-fi movies, to reach to that stage, it's far beyond present what we are in. So we are at artificial narrow intelligence stage, which also called as weak AI, whereas artificial general intelligence is called strong AI, and artificial super intelligence is called as super AI. So these are the three broader classifications of types of AI at present, and many journals may have further more classifications, but at a broader scale, this is what it is. Next is why Python for AI. So as I said, Python is something that is an open source and it is broadly used for AI. For example, if you take any other language when compared to Python, the number of lines of code that you write in Python is much lesser. So maybe 1/5 of the lines that you write, if you compare C and Python, in order to execute a particular task, you will be writing, if you write 50 lines of code in C, you would be completing the same task in 10 lines of code in Python. So very less code is required. As AI requires a lot of coding, Python would be the better tool because it requires very little effort. I don't say nominal effort, but it requires a little effort more than regular algorithms. But if you do it in Python, it will be less cumbersome. Next is the other feature that Python have is the pre-built libraries that we have in Python. Python, as it is became very popular, so a lot of enthusiasts actually automated most of the algorithms. I mean to say, they have built the functions wrappers where you can just pass in the parameters into the functions and get the output required. So if you want to create a particular news article from a website, you have pre-built libraries like a newspaper 3K. You have a beautiful soup which can automatically get the HTML code from the web pages and script the news articles. So like that, we have a lot of pre-built libraries like NumPy, which actually computes the mathematical computations faster. And we have pandas, which we generally use for data analytics work, where if you want to aggregate the data at a different level and if you want to see the insights at it, you can use pandas. And you have scikit-learn, which is most popular machine learning library that we have, and that is a pre-built function available as pre-built function in Python, where users can pass in the input data, training data, and train the models within the scikit-learn. So examples of algorithms within scikit-learn are, maybe you can use linear regression, you can use logistic regression, you can use random forest, decision trees, where you pass in the input training data, you can train the algorithm, and you can forecast the future by just giving the independent variables where the dependent variable can be forecasted. So all these tasks get simplified because of a large amount of pre-built libraries that are available in Python when compared to other programming languages. And ease of learning. So Python is the most, as far as programming languages that I came across, I felt Python is the most easiest language that anyone can learn. Even the industry have the same understanding of Python, that Python is the one of the easiest languages to learn, and you don't need to spend a lot of time in learning Python. You can just focus on how to implement a solution if you take Python as one of the coding languages for AI. And the other thing is, as Python is very popular, it has a lot of massive community support. If you get stuck in any particular point while coding in Python, you can pose that particular question in any community, where you will initially, like, you will find answer in the search itself. If you are not able to find answer for your query, you can post that in any of the communities where you can get answers, because a lot of enthusiasts post answers for the questions that people raise. So you have a lot of massive community support for Python, because a lot of developers or machine learning scientists using Python as one of the programming platform these days. Next is platform independent. So Python is platform independent, as if you code it in Ubuntu, you can still move the code into Windows, and it is completely platform independent. With small changes in the code, you can easily move the code into any of the operating systems. So because of all these features, so Python is one of the right choice for using it in order to implement AI algorithms. So next, even Stack Overflow, it is one of the website where people post the questions and even people answer the questions that other developers posted. When it is compared with C++, PHP, C Sharp, Java, and JavaScript, so Python had an exponential growth starting from 2012 in this particular graph that it shows. So even though it is comparable with Java and JavaScript, but the growth that Python has received is exponential. So a lot of people getting onto this platform, they are learning Python because Python is easy to learn. And using Python, it is not just AI algorithms that you can build, but you can do a lot of other things as well, like building interfaces, building web pages, or automating processes. All these things you can do using Python. So Python is an open source programming language, and you can either build an object oriented programming style using Python, but it is not necessary to do it, because even without following oops, you can execute, or else you can build a tool using Python. So that's the advantage of Python when compared to other programming languages. So this is the most widely used and fastest growing programming languages. It's a very good programming language for machine learning, data analytics, and artificial intelligence. And most of the libraries that are built for deep learning are built using Python. The most popular one, example Keras, which we will be talking in our coming slides. So next is Python packages for AI. So the first one that we are going to talk about is the TensorFlow one. So which is the most famous one because it is first developed in Google by a team called Brain. It is popularly used in writing machine learning algorithms where it is very much similar to the concepts that we use in MATLAB. So MATLAB is a academic programming language which earlier used to be people used to use in algorithm trading and investment banks. So where when you deal with matrices or higher dimensional arrays, MATLAB will be used. So MATLAB can be comparable with TensorFlow, but TensorFlow is an open source and where you can do matrices operations using TensorFlows. And because of that concept, TensorFlow is a right library to be used on deep learning because in deep learning you connect between different neurons, you connect between different layers, so multi-dimensional activities happen in deep learning. So TensorFlow is a library which helps you doing it much faster and much efficient. So there are features of TensorFlow which actually helps people to use it more effectively. The first one is the responsive construct. So as I said earlier, TensorFlow works on matrices concept. If people have difficulty in understanding what is a matrix, it is more like a graph approach that they follow in TensorFlow, where each of the data points get connected with a graph or a continuous line where information flow happens between the data points through the graphs. So for example, if you take a deep learning network, layer 1 to layer 2 and layer 2 to layer 3, the information flows through the connected graphs and the weights gets adjusted in order to improve the results. So all this entire stuff very well get done in using TensorFlow because of its responsive construct. Any of the changes in the weightages because of the propagation happens can immediately impact the other neurons because of the responsive construct, because of the graph theory that they follow in the TensorFlow. So next is the flexibility that TensorFlow gives us. In TensorFlow, we have the modularity concept where initially you can start a session, later on you can assign the weight, later on you can run a function for optimizing the equation in order to reach to the global minima. So even though you won't have much play in tweaking the optimization algorithms in TensorFlow, that is one drawback that TensorFlow has, but it helps you to keep one task separate to the other one in the deep learning architecture. So that is one flexibility that TensorFlow offers. Next is easily trainable. So easily trainable is like if you train deep learning network on a CPU, you can easily move it to GPU as well, whereas CPU is central processing unit, whereas GPU is graphical processing unit. Nowadays, we also have TPUs, which is tensor processing units, where NVIDIA offers this. Actually, TensorFlow is a bit slower when compared to other deep learning architectures like Keras and Theano. But when it is used on GPU and when it is used along with the parallel processing, TensorFlow is much faster compared to other deep learning libraries. So the parallel neural network training that is offered in TensorFlow helps in faster training and faster convolution of the optimized network in deep learning. So that's the reason for the production environment, people generally go with TensorFlow architecture. If it is academic or else it's a POC, then generally people go with Keras or Theano. And TensorFlow before October 2019, it is not supporting Windows, but after release of TensorFlow 2.2, we can use TensorFlow even on Windows without the use of any of the Docker environments. So that is the advanced use of TensorFlow, and this is one of the library that you have that is available in Python. So we also spoke about parallel neural network training. Next is scikit-learn. So scikit-learn is a Python library associated mainly with NumPy, SciPy, and a lot of machine learning libraries are available in scikit-learn. So this is one of the most famous library for machine learning in Python. There are multiple features, there are multiple algorithms within scikit-learn library. The first and the foremost thing that we are going to talk about is the cross validation. So cross validation is a concept which helps algorithms to get trained holistically, where you won't get trained if you have 100 records, and if you're training your model on 80 records and you're testing it on 20 records. So what in cross validation happens is it will put back the rest of the whatever the 20 records that we left for test back into the train, and pick 20 train records and build the algorithm again and test it on the revamped 20 records. So this is a concept which actually became popular and for building better algorithms, where in scikit-learn you have libraries, pre-built libraries, where you just can pass in data into the cross validation function and give the split percentages, and it pops up the cross validation folds along with the outputs. So cross validation is mainly used to compute different algorithms, how well it is performing on a particular data. Like linear regression, you have random forest regression, decision tree regression. But among that, if you want to select one particular regression algorithm, you can use cross validation. Or within an algorithm, while changing the parameters, if you want to identify which is the parameter combination that is working better, you can do it using cross validation. And other set of algorithms that are available in scikit-learn are unsupervised learning algorithms. So examples of unsupervised learning algorithms are mainly clustering algorithms falls into unsupervised learning algorithms. Example is k-means. You can also go with knn, you can go with k mean shift. So all these are clustering algorithms. So generally clustering algorithms are used in customer segmentation problems, where if you don't have a pre-trained or else trained labels available, you can take the data based on the way that data is clustered according to the intercepts that they have on the xyz, or more if it is a higher dimensions, it will have higher intercepts on each of the axes. So based on the location of the data, it actually categorizes the customers. So that's where unsupervised learning algorithms comes handy. So these are unsupervised learning algorithms. We have very good libraries in scikit-learn, where very easy to use and very easy to implement as well when it comes to production environment. So the next feature is feature extraction, which scikit-learn for its algorithms that it offers. So if you have 100 features in order to predict a particular outcome, you may not use all the 100 features. If you want to go use only the top 10 features, out of these 100 features, you can use feature extraction algorithms to identify which 10 features among these 100 features you can select and train the models. So those sort of feature extraction algorithms are also available in scikit-learn. The algorithms that I, in my personal experience, use are select k-best methods, recursive feature extraction techniques. All these are very much available in scikit-learn. Nowadays, we have other competitive libraries available apart from scikit-learn, but I feel most of the developers or machine learning experts use scikit-learn as their first go solution for any of the algorithm use. So next is NumPy. So NumPy is the library that is mainly used for mathematical operations, or computing scientific multiplications or computations. Is NumPy is used because here the use of three-dimensional or more higher dimensional arrays are used. Because of the support of multi-dimensional arrays, NumPy is the most effective library for mathematical computation. So actually, you can do the mathematical operations using other libraries as well. NumPy is the library which people specifically use on numeric data, and here they have the vector concepts which actually make the computation process much faster. So that's the reason people go with NumPy. So, and this library is also available in Python. So whatever the libraries that I'm talking now, all these libraries are available in Python, which actually help in developing an AI or ML solution. We can also do numerical analysis using NumPy, where if you want to plot a distribution curve, if you want to calculate mean in a particular distribution mode or a median, you can easily do using NumPy library. So NumPy is very intuitive. Actually, it is the far most used libraries in Python when compared to other libraries. The two most popular libraries that used in Python are NumPy and Pandas. So people can check that out. Next is Theano. So Theano again is a deep learning library. So Theano is a Python library that allows you to define, optimize, and evaluate mathematical expressions involving multi-dimensional arrays efficiently. So we spoke about TensorFlow, we spoke about NumPy. So Theano is, I feel, in my understanding and my experience, Theano is the most first known deep learning library where people started using initially for the academic purpose. One good thing in Theano, if people are very good in coding, they can even code the optimization algorithm in Theano, because there is no predefined optimization happens in Theano, where you will have complete grip of optimization that happens in deep learning networks. So the advantage of Theano is that, where you have complete grip of what is happening within the deep learning library. If you want to have that, then Theano would be the best choice for you when compared to TensorFlow. And Theano is much faster when compared to TensorFlow when it is used on a CPU, but Theano faces difficulty while doing the parallel processing. So that's when TensorFlow has advantage when compared to Theano. So Theano can be defined as a library for scientific computation. So this is initially built for doing mathematical expression researches, where derivatives of a particular equation, integrations, and everything happens very free flow in Theano. It is a very pronounced library when it comes to mathematical operations. It allows you to define optimization, as I said, where you can build your own optimization algorithm using Theano, whereas TensorFlow will not allow doing that. And evaluating multiple mathematical expressions can also happen effectively in Theano. It can run both on CPU and GPU, but when it comes for parallel processing, it actually has less advantages than when compared to TensorFlow. But Theano is the older one, and there is a lot of community support as well for Theano. TensorFlow, after October 2019, we can use it on Windows, whereas Theano, right from the beginning, you can use on any operating system. So that is one advantage of Theano. Next features of Theano is tight integration with NumPy. As I said, Theano is the library that is invented to do mathematical operations, effectively the integrations and differentiations. When it integrated with NumPy, it becomes much faster for computational exercises, and it can be used very well on GPU. The only drawback it has is when you are doing parallel processing, it actually sacrifices some speed. That is the only drawback it has. So people generally, while building POCs and initial research projects, they use Theano extensively. And for testing, so especially in deep learning product environment, Theano library is used more for running different test cases. And because the other pronounced libraries like TensorFlow may not allow you to tweak in the optimization, whereas Theano allows it, where you can come to a point which optimization library or what is the initial weight set that you want to use, you can come to, or you can deduce to that point using Theano. So it is extensively used in research projects. So next, coming to Keras, TensorFlow is the most popular one. Keras is the most widely used deep learning library when compared to Theano and TensorFlow, because it is very easy to use. In my experience, people with whom I worked, most of them use Keras. So Keras is very simple. It simplifies the implementation of neural networks. It has a lot of algorithms available in it. You can implement neural network within neural networks. You can implement artificial neural network and multi-layer perceptrons. You can implement RNNs. You can implement LSTM within RNNs, and you can also implement neural networks without much difficulty, because it's a very simplified version of deep learning library, which is again built on Python. Because it is built on Python, when you use it with Python on deep learning, it is much faster. So a lot of companies like Netflix, Uber, even music industry like Ghana even uses Keras for their search engines when they are padded with the deep learning library search engines. So Keras is the go-to tool for me in my experience for deep learning implementations. And even Keras can be used along with Theano or TensorFlow. So Keras has that advantage, getting integrated with any other deep learning libraries if needed. So Keras also provides some of the best utilities for compiling models, processing data sets, visualization of graphs, and much more. So if you want to visualize how different neurons getting changed over a period of time during the training of the data sets, you can visualize very well in Keras. And you can do the same thing in TensorFlow as well, using TensorFlow visualizer called TensorBoard, where you can see the lifetimes of a particular neuron in TensorBoard by tweaking in the weights and optimization algorithms. Similar features you have in Keras as well. So it runs again. The features coming to Keras is it runs smoothly both on CPU and GPU, just as our other deep learning networks like deep learning architectures like Theano and TensorFlow runs very smoothly on CPU and GPU, and it is much faster as well. And actually, Keras have a competitive advantage when compared to TensorFlow and Theano is that uh, it can run parallel processing very well, both on CPUs and GPUs. And it has a lot of libraries where you can directly get a particular, if at all you want to use convolution neural network, you just need to pass in the data and the parameters into it. You don't need too much code in it. You don't need to write an optimization algorithm. You don't need to write any of the neural network that you decided to use from scratch, because it has pre-built libraries and it is easy to understand as well. So supports all types of neural networks. As I said, it has its libraries for RNNs, CNNs, MLPs, multiply, and even on text data, Keras is very well used, and it is completely based on Python, as I said. The last one is the natural language NLTK kit. So generally, when people start using or try want to make their hands dirty in natural language processing, they start with NLTK toolkit. It's again an open source Python library for natural language processing, where the text analysis, text mining, sentiment analysis will be done. Actually, NLTK has a lot of pre-built libraries. We call it lexicon libraries, where if you want to get a sentiment out of the data, you can use the built-in libraries within NLTK. You can train your model and you can get the output based on the test set. So all these features are very much available in NLTK. There are concepts like lemmatization, where lemmatization is a concept where two words have same meaning. NLTK lemmatization process considered it as a single word. And you can do stemming. Stemming is like, for example, coming and come actually can be considered as a single word using stemming. Stemming just removes the ing part in the coming and then makes it come. So it is more the same. That's how you can reduce the word count within the corpus. So those features are very much available in NLTK, and this is the most widely used NLP toolkits that are available. So, and this NLTK, actually NLP became popular and people started using Python for NLP is because of NLTK, I feel. And I have even used during my master's NLTK toolkit for my master's project. And during that time, NLP is gaining popularity. So I think like most of the people who actually working on NLP may at least once in their experience might have used NLTK. So NLTK is very much well pronounced in Python. So it has a lot of libraries and a lot of built-in functions. So we can do text analysis. So text analysis, if you take ratings given to a particular product by a group of customers, if you want to understand what are the key things that they're talking about this particular product, you can do text analysis using NLTK toolkits on top of it by removing the stop words, removing the parts of speech which you don't want to have. All the tasks can be done using NLTK toolkit. Next is sentiment analysis as well. You can do using NLTK. So we have Vander Sentiment is a library which is available in NLTK, which actually tags the words whether it is a positive or a negative word. So based on number of occurrences of positive words or negative words in a sentence, you can classify that sentence as a positive sentence or a negative sentence. So all these sentiment analysis can also be done using NLTK. So all these features make Python the most popular choice for AI. And as you have mathematical computation libraries, and you have deep learning libraries, you have machine learning libraries, and you have libraries that actually uses and tweaks the text libraries. Everything is available in Python. So Python is the most popular choice here. So thank you for the session.